Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to demonstrate how to use arrays in C++. So I'm going to open up Visual Studio, create a new project, I'm going to call it Arrays Demo. I'm going to save it on the desktop and click OK. I'm going to pick the console subsystem in my empty project so that I can, when I run in non-debug mode, it will leave the console open. And I'm going to add a new item, a C++ file which I will call Arrays Demo as well. I'm going to include my the IOStream library, and we'll use the standard namespace. We'll start our main method. And to begin, let's declare a integer array. So we're going to use the int keyword, which declare is the type. Numbers will be the identifier for our array, and in square brackets we'll place the number 10, which means that this numbers array will have 10 elements. That declares array just like we would declare a regular variable. The only difference is if it's an array, we identify the number of elements in that array. And we're going to use a for loop to display what's currently in the array right after we've created it. And to get at each element, we'll say cout numbers of I. And put a carriage return at the end of each one. As we can see, the loop structure is actually very well suited for arrays. We start with I equal to 0. Remember that arrays begin with element 0, not element 1. And then we will continue incrementing I until as long as I is less than 10. So that will get us numbers from 0 to 9, and even though we created a 10 element array, realized that the indexes of those elements in the array go from 0 to 9, not 1 to 10. So this is the proper structure for building your for loop to get each element. You'll notice also that we haven't initialized the elements in this array. So I wanted to display first what this, when you just initialize an array, what you get. And so I'm compiling it. And you can see we have essentially unpredictable values. The largest negative number possible for an int is what looks like what's being stored in each of these elements. So before you can use an array, you really we need to initialize it. And for our purposes, what we're going to do is we're going to loop through this array and initialize each value to the number 5. And when I do that, we have one loop that goes through each one and initializes it to the number 5, and then another loop that goes through and then displays each element of the array. And we can see here that in fact the array is now filled with the number 5. So obviously you could do anything you wanted with this, but there would have to be some kind of calculated value to place in there. Suppose we wanted to find the cube root of each, the index of each element in the array. What we could do is include the CMath library and then down below numbers of I could equal power, which is the power function from CMath. The first element is we're going to use the integer I, and then we'll raise it to the cube root, so we put in 3, and I will now equal the element in numbers at I will become the cube root of its index. And if we run that, what we see is the first element is 0, 0 to the third power is 0, 1 to the third power is 1, because 1 times 1 times 1 is equal to 1. Then 2 to the third power is 8, 2 times 2 is 4, times 2 is 8, and so on and so forth, all the way up to the cube root of 9. So that's using a function. Of course, these aren't necessarily extremely useful functions for the most part, but they demonstrate how we can do some calculations. What would be much more useful is if we had a way of actually specifying each individual value, and we can do that. I'm going to change this to an array of floats just so that we can see that we can make an array be of different types. And to initialize an array to specific values, what we do is we set the array equal to a list of those values between two curly braces. And in this case, I'm going to make these floats 1.1, 2.2, 3.3. They could be anything I wanted. And I don't want to put that many in, type that much. So I'm just going to make my array be 5 elements long. And we'll loop through this new numbers array and see out the numbers and see what gets displayed. And just to make it more interesting, I'm going to say value at I and if I run this one, we can see the value at 0 is 1.1. The value at 2, or the value at 1 is 2.2. The value at 2 is 3.3. The value at 3 is 4.4. Remember, our indexes are zero based, so the first element in this list of numbers between the curly braces is going to be 1.1, the element on the first element of that list. We could also create an array of strings. So let's say we had an array of strings with 10 numbers in it. All we do is specify those separated by commas again. And so I'm going to put in some names. And these are names of a few computer scientists which have had some impact on the world of computing. And we can display them using our loop. I'm going to change the name of this array to names. And let's see what this one does. And we notice that there's a problem here with the operator. Well, it turns out we need to also include the string library when we work with these strings. Then we see the red squiggle goes away. Let's see if that actually compiles now. And it does. And so what we see is all these names in this array of strings now can be displayed. Now, one of the conditions that can happen is that our array can go out of bounds, and a common way of displaying this is, suppose we displayed an integer array. Let's say create two arrays. We'll create a high array with four elements in it, and a low integer array with 4 elements in it. And what I've done here is I've declared two arrays in this one line. They're both going to be integer arrays. One's just going to be called high and one's going to be called low. So you can declare multiple arrays on the same line, the same way you can with variables. And let's say that we wanted to initialize these, and we said low of I is equal to, just arbitrarily, I plus 5, just to have a value to put into there. But rather than saying I less than 4, we accidentally said I is less than equal to 4. So this is a common way to improperly construct a loop for an array. And we do the same thing with high, only we'll say I plus 100. So we're actually going from 0 the indexes are 0 based in our arrays, but if we accidentally say I is less than or equal to 4, we go from 0 to 4, which is actually 5 elements. Since there's only 4 elements, this is actually going to step over outside the bounds that we allocated for this array, and it will actually create an error. So if I run this, it actually compiles, it actually runs, but you notice that we get an error. Runtime check failure 2, stacker on the variable high was corrupted. And basically what happened is when low basically ran into high's memory space. So it's important to make sure that you structure your for loops properly when stepping through your arrays. And this completes my demonstration of building arrays in C++. Thank you.